We want to welcome everybody to the J&J Show, sponsored by Milton Industries, the family of companies under Milton. Z-Line by Milton, LTI by Milton, Promax by Milton, and we don't have our banner updated yet, but they've also added now Steck by Milton. And so we're so appreciative of them. Milton just does a great job taking care of us and sponsoring this show so we can reach out and share all the new tools, technology, and training that's available in our industry.
Thanks, Jeff. John, thank you guys for having me. I'll try to make this as quick as possible, but still informational at the same time. Today, we're going to be talking about the scope tips for GDI on the J&J Show. And my name is Oscar Gomez. Jeff was saying, I am from Southern California, born and raised here in Southern California. I didn't remember California being this horrible till it is now. However, we're going to talk about a good tip on GDI. I was talking to Jeff a little bit, and he was mentioning that he's been hearing a lot of feedback where people are saying, well, you know, what are certain things that are going to occur with the GDI vehicle, and what are certain things that a technician needs to know, how to particularly use a lap scope to run some basic testing on any GDI vehicle that you guys can use as preventive maintenance, or as if the vehicle comes in with a fault, then you can actually run this particular test and get you guys some information. So to get you guys started, who's Oscar and who is that guy, right? I always start off with letting everybody know that I believe strongly in bettering the automotive industry one technician at a time, and this starts with you. So anybody who's watching this video today, I'm a firm believer in helping you become better. By doing so, then you're going to go out into the field, do your magic in a better fashion, more productive, and also make sure that you have less comebacks, and that's going to help us better the industry as a whole. I also believe in an investment in education pays the best interest. By that, the more you put time and money into yourself, the more you're going to increase your value. The more valuable you are, the more you're going to get in return or in compensation, either as a technician, shop owner, etc. Most guys think that us as educators, we somehow just woke up one day and we're at where we're at today. It's not that way. We all started at the bottom. I know I started at the bottom. I was a shop guy, so I got to clean the shop, check inventory, clean out air compressors, empty out the drains, mop the shop, pressure wash the shop. So that was all my tasks. Slowly but surely, I moved into the lube tech role, where one of my initial mentors, Benjamin Franco, was the one who actually introduced me into the maintenance side of automotive. After that, here in the state of California, we do emissions testing. He was the one who suggested that I go get my emissions inspector license. If it wouldn't have been for that, I would have never met my mentor, which is Mr. Don Wilson. Don is probably the one who is responsible for where I'm at today. He was the one who offered to mentor me, not only to become a better diagnostician, but also to become an instructor. And now it's my job to pay it forward. So I'm happy that John and Jeff and J&J Show has me on here today. And I'm hoping that with whatever the small amount of information I'm going to share with you guys in the next about 10 minutes or so is going to be definitely worth it to help you guys head out there and help us better the industry. So if you guys are ready, I'm ready. Let's get going. So today's learning objectives is just, we're going to go over why a lap scope, common GDI issues, and we're going to talk about delta sensors for vacuum testing. If you have no idea what those are, don't worry about it. We're going to get there. Whoops. All right. Good pressure waveform. So if you guys could do me a huge favor, what you guys are seeing here on the screen right now, this is a waveform that I'm actually looking at now. And if you guys can put in the chat, if you guys see anything wrong with this waveform, what you guys think this waveform is for, and if you spot anything wrong with the waveform, how can that help me as a technician on this particular car that I'm working on? Go ahead and take about maybe 10 seconds or so. If you guys know anything, put it in there. If you don't, just say, don't know, and then we'll go from there. So we'll do a quick countdown. And if you guys know, great. If you don't, it's okay. I'm about to share with you. I like to start with this waveform. The reason being is this is actually a waveform from an EKG. So if you guys ever been to the doctor when they hook you up to monitor your heart, this is what we're actually seeing. what this is what this is crazy is that if in the medical field they're actually using oscilloscopes and lap scopes not only for heart patients, but you know, 3 years ago when my wife was giving birth to our last child, I was actually able to read the waveform when she was having contractions. So it's the same thing as automotive. So if the medical field is using oscilloscopes, what's the excuse for the automotive technicians working on the newest cars out there that don't use lap scopes? I hear this a lot where a lot of guys say, well, I don't need a lap scope, I could do it with the DVOM. That's true, plausible. However, if you realize when you're talking about, just like Mike was talking about with CAN bus, you got CAN bus that's running at about 5,000 megabytes per second. So these things are fast. Your voltmeter can't get enough samples of that information. This is why we need to use lap scopes. But for me, I'm a big proponent in actually using oscilloscopes. They're very beneficial, especially when it comes to diagnosing. You're going to see a picture of what's actually happening. And if you guys aren't aware of this, the majority of automotive technicians are visual kinesthetic learners. So we need to see and do in order for us to actually learn something. If you guys apply Ohm's law onto an oscilloscope, you're going to see a digital representation of what's actually happening within that circuit or component. This is why an oscilloscope is such a powerful tool for us as technicians, and particularly with newer cars that are actually coming out into the field. So one of the common issues we see with GDI, now that we're injecting fuel directly into the combustion chamber, we no longer have the cleaning effect of fuel on the face of the valve. Because of that, we're beginning to see a lot of carbon buildup. A lot of manufacturers are actually recommending a intake decarb on a regular basis. The problem is most consumers are just worried about, did my car start? Did I make the payment? And do I need to take it in for service? They're really not up to par or ever read the owner's manual. It's in the glove box to know what the service that's needed on the vehicle. That's when we come in. Us as technicians, our responsibility, and shop owners and whatnot, our responsibility is to educate the consumer. One of the ways we can do that is by making sure that we're constantly letting them know of new updated changes, such as a decarb when it comes to GDI. Now, if you guys have a GDI vehicle, there's multiple ways that you can actually run a decarb on the actual system. One could be if you're using something like the all-tool walnut blaster, or the new ice blaster, and then you can go old school with chemicals. B&G makes it good cleaner as well. So this is stuff that we need to be offering our customers. Another thing too, when it comes to GDI, that's always recommended is advising your customer to reduce idle time. The more the vehicle is idle, the more likely you are of building carbon buildup. So these are stuff that we need to communicate over to our customers. This is a very common issue. And if the customer is not aware of this, then they'll become aware of it when the vehicle comes in, because they're having a rough idle, vehicle stalling, or in some cases, some detonation. Okay, so it's always a good idea to make sure that you guys are on top of it and educating your consumer about these related concerns, especially if it comes to a GDI vehicle. Now, one of the questions that I usually get commonly asked is, how would I determine if this thing has carbon buildup? Well, the easy answer is pull the spark plug out, get an articulating borescope, drop it in there, and then bring it up. And sometimes you might be able to see the carbon. If not, then you're going to have to go this route. Not sure if any of you guys have ever done this before, but what I have here on the screen is using my Pico 4425. I'm doing a relative compression test, which is in blue. I'm doing a vacuum test in red, and I'm doing an in-cylinder pressure test in green. These three tests are actually very well needed when you guys are trying to determine if you have a mechanical integrity issue. And this is why I run all three tests at once. So this way I have a better idea is, how is this engine mechanically sound, right? Now, one of the questions I always get is, why can't I just use a vacuum gauge? Well, a lot of manufacturers are turning to the Atkinson cycle instead of an Otto cycle engine, and that's going to affect your vacuum reading. So the best option here would be to use something like this, because this is going to give you a visual representation of what's actually happening. When it comes to sensors for oscilloscopes, there are two different types of sensors that we can commonly use. The first one that we can see here is this black one with a, geez, I'm having brain fart today, with the quick coupler. This one right here is a absolute sensor. The one to the right, the green one, good friend of ours, Cody Gotti from Cody's Diagnostics, has provided us with these sensors, and we love them. We use them for everything. Okay, so there's a difference. The delta pressure sensor simply just shows a relative change. So it'll either go up or down depending on the type of change, but it's not measurable. So we can't really measure it and say, okay, because it's this much voltage equals this much pressure. With an absolute, it actually calculates a pressure to a specific voltage. Absolute sensor should bring something to mind: manifold absolute pressure sensor or a MAP sensor, right? We can actually, depending on the vacuum that we have on that sensor, we can get a voltage readout, and that's how we know what the vacuum is on that particular sensor. Okay, so those are the two common ones that we use. What I did here is I have both of them on a vacuum hose, and I applied vacuum. This top one right here is going to be a delta pressure sensor, and like I said, a delta pressure simply just reflects change. So if you guys notice, we went ahead and put positive pressure. So I blew into the hose. My delta sensor simply gave me a small peak, and then it leveled back off. So it did tell me that there was a rise in pressure. However, it didn't actually continue to demonstrate that pressure. It just dropped back off. On my blue absolute, you guys can notice that the moment I put pressure in it, that pressure sustained and it went across for a long period of time. When I released the pressure, my delta pressure sensor went into a negative pressure reading, where my absolute simply just leveled off and then flatlined again. It's always important, if you guys are using any one of these two, this bottom one in black, if you have a Pico WPS, it is the same thing. Your Pico is an absolute sensor. So that one would actually do pressure and vacuum. Okay, so always make sure you guys are aware of what your tools are capable of doing and what they are not. I don't have some slides up here for it, but I'll talk about it now. This Cody sensor actually duplicates very well for a lot of different things. I've actually attached it to a dipstick for engine oil to check for engine blow-by. I've also used it with my stethoscope attachment and hose to use it as a digital stethoscope. Inside of it, all it really has is a piezoelectric wafer chip that detects pressure change. So you can use that sensor for a lot of different things. I've used it in the exhaust, I've used it in the intake, I've used it on the engine coolant. Take the cap off, put an adapter, put that hose on there, crank the car, synced it to cylinder number 1 ignition, and then every time I got a spike, that's how I would be able to determine which cylinder was going into compression at that specific moment, and that told me that that cylinder had the blown head gasket sending compression into the cooling system. So a delta sensor is a really useful tool. If you guys aren't using them, I would strongly advise you guys to start picking them up. This is not new technology, by the way. This has been around for years. When I started in the industry, we all had those big box scopes, and they had all these attachments. It's just that slowly it kind of died down, but that's coming all back up. So I would advise you guys, if you guys aren't doing this, to start using them, because you can use these very universally in automotive. What I did here is just a quick zoom out. You guys can see again, I have my green in-cylinder waveform. So that's telling me all 4 events within the cylinder: intake, compression, power, and exhaust. And then my blue waveform right here is my vacuum. And then I have my red waveform is my vacuum. My blue waveform is my relative compression. Okay. All right, so now let's get into the nitty gritty. Whenever a car comes in, the picture you guys are about to see is a Hyundai, which is very common for carbon buildup. When a car comes in and a customer is complaining about erratic idle, rough idle, feels like it's misfiring a little bit, you might want to check for carbon buildup. This car that came in, customer's concern was hard start and rough idle. So we went ahead and did a delta pressure sensor test. So you guys could see in the blue waveform, that's my relative compression. And right below that in red, that's my actual vacuum within the actual cylinder as the vehicle was being cranked. When you take these waveforms, the vehicle needs to be in a cranking state, not a running state. In a running state, there's too much happening where you're gonna have a lot of anomalies that you think might be a problem, but in reality, they're not measurable. So the best thing to do whenever you're checking for carbon buildup on a vehicle is do it cranking, key on engine cranking, not key on engine running. Okay, so what you guys could see here is notice all this hashiness on my vacuum trays. This hashiness is indicative of carbon buildup. As the airflow is going into the cylinder through the valve, it's actually going to be all over the place because of the carbon buildup. This is why we get that hashiness in our actual waveform. When we went ahead and did a visual check, you guys could see all the carbon buildup on these actual valves. So this right here would just confirm what we already saw on our previous waveform capture, which was this one right here. So looking at this waveform capture, we can tell right away that we're gonna have to do a decarb on it. Now, if you want to confirm that, you can always charge the customer to remove the intake to go in there. Or what we do is we see this and we tell the customer, you have carbon buildup, we recommend a decarb, and then we do an after decarb analysis. So once we went ahead and did the decarbonization, this is what the waveform came back looking like. So you guys could see we still have a little bit of unevenness, but it's a lot less than what it was prior. So showing these two pictures to your customer side by side, they can see that you actually did something, even though you don't have pictures of inside the actual valves or the actual combustion chamber, but they can see there's a huge difference between the noise that was prior to the decarb and then what you see after the decarbonization. So I'll go back to that one so you guys can see it again. This is what it looks like when it has carbon, okay? And this is what we get after we do a decarbonization. All we had connected here was an amp clamp over the battery and then our delta pressure sensor that was connected to manifold vacuum, and we were just cranking the car. Okay, so it's not a very difficult test, very easy to do, and it helps us be able to identify if we need to do an engine decarb. Or we can go old school, take up some time and take some stuff apart. I'm not a big proponent of taking stuff apart when I don't really have to. So if I can run these particular tests and lead me in the right direction, then I'm sold, right? And with that, guys, that was pretty much all I put together for you guys. So I hope that you guys can take the knowledge you just learned about delta pressure sensors and absolute sensors and how to verify if you have carbon buildup in your GDI vehicle, and also start incorporating GDI maintenance for your consumer, because this is going to help you guys a lot when it comes to, one, having your customers content with your service, and then also keeping your customers from breaking down. All right, so that is all for me. Jeff, John, Mike, everybody on here today. Kevin, I really appreciate you guys being on here. Thank you guys for having me. And if there's any questions, I'm open for questions.